on, Echo. I got the music playing in the background. So, how are we all doing today on this lovely Monday? It's actually kind of nice out. I thought it was supposed to rain today. I don't know if it's raining down by you guys, though. Let's see here. Yeah, it's showing everybody starting to jump on now. So if you guys are just getting in, Unit 11, Lesson 3, let me know if you guys have any issues downloading it. We're going to do a little geometry review today. Yeah, I definitely would get outside if you guys can, because they're calling for rain every day this week. Today's going to be it's going to be more of like an introduction to what we're going into. It's adding in what we've been doing the last couple of days. Yeah, I'll send it to you right now, Shannon. Let me just disconnect real quick. So what I plan on doing is doing the little introduction, and then I'm going into what we did last time, but with trig. So that will be the second page. That's what we'll be doing tomorrow. Shannon, what I will ask you to do is, as I'm about to wrap up the lesson, let me know so I can send you the homework. I'll basically just send you everything in one email, but I'm definitely going to forget if you don't remind me. All right, so let's see here. Are we starting to fill up now? We got a few people here and there. It's a little bit lower than it normally is, but I'm just going to assume people are going to be watching on YouTube. All right, so first thing I'm going to do, I'm going to start off with some stuff that we did in geometry last year. And I kind of mentioned it if you joined up in my Zoom calls. It's something called SOHCAHTOA. A lot of you guys have learned this different ways. It depends on who your geometry teacher was, but I think everybody that's in Algebra 2 this year had Miss Randolph for geometry. I could be wrong. Some of you guys may have had Miss Bielzik, because she also taught geometry, and Mr. Courteau taught geometry as well, but I don't remember if you guys would have. I think Mr. Courteau was already down in the 8th grade before any of you guys would have had him. I could be wrong. So the thing I'm going to write down looks like this. So it was SOHCAHTOA. So this was one way trig is shown. I don't believe Miss Randolph really went too crazy with this. Miss Randolph probably had you guys write something that I'm going to do below. That looks something like this. If you have sine theta, that is represented by O over H. If you have cosine theta, that is represented by A over H. If you have tan theta, that is represented by O over A. So if you guys are looking at chat, you'll see what Tabitha just put down. That is the way that Miss Randolph has taught it in the past. If that helps, I will continue using that. So Silver Creek teachers, it's all an anagram. So what we're looking at is just at the first. Oops, I thought I was on highlighter. I was not on highlighter. But we're just looking at the first letter in each. So the SCT stood for Silver Creek Teachers. And I'm just going to write it underneath because some of you guys may want to go back to this as you're writing it down. Luckily for you guys, since everything is being done online and whatnot, it's all open note, so you guys can always just go back to your notes if you forget it. But that stood for the Silver Creek Teachers, and the OHAH and OA stood for Oscar had a heap of apples. So I could write those down as well, just so you guys have it. Oscar had a heap of apples. Okay, so that's how she taught it last year. I'll continue on with that unless you guys have heard something else or that's confusing. Last year I had to do like 3 different methods because everybody had different geometry teachers. So we have a nice universal one. I'll just stick to it. So when you guys were introduced to these trig functions last year, you didn't really get an explanation why. You guys were just taught, hey, it's part of a right triangle. So we're going to do what Miss Randolph says because that's how math works. That explanation is going to kind of continue on to a certain extent, except it came from something called the unit circle. So the unit circle is what we did last time. So the unit circle is used in this picture right here. And you're going to notice that the coordinates are in there, just like we did in the last lessons. And this was part of your homework. You guys were asked to find the coordinates of whatever the given angle is. So what we're going to be doing today, and it's just for today, we're going to do more of the math tomorrow. But again, today's more of an introduction. I'm going to focus on using just variables because I want you guys to understand that everything that we're going to be doing within the upcoming days is just like what you did with Miss Randolph, except I have to introduce you to a new unit. So you guys did it in degrees last year. So if you were given an angle in degrees, you were asked to find the exact value of whatever the given right triangle was. There's another mode that we're going to be doing on our calculator, and it's called radians mode. Radians mode is used a lot when you go into the upper level math courses because it's easier to use than degrees. For you guys in Algebra 2, it's more or less just kind of an introduction lesson, so some of you may not like it at first, but your calculator can solve it all for you anyways. So the only big thing is I'm going to have to show you guys how to change the mode on your calculator. It's not really going to make a big difference. You're just going to have to make sure you read the problems carefully and see if the question's asking for radians or degrees. That's going to be a big lesson for Wednesday when I start introducing all that. So today, I'm just going to call it theta. We're not going to be working with any unit. We're just going to call it theta, okay? So based up top, I'm going to start with exercise number 1. We're saying that we're starting with sine theta. So as we said right above it, sine theta is equal to O over H, which O stood for opposite and H stood for hypotenuse. So I'm just going to rewrite O over H. And now what I'm going to do is I'm going to come over to this right triangle that we have off to our side, off to the right, that's inside the circle. Now, since we're using the angle theta, we're actually starting on the inside of this triangle. So if I look at that theta, it says that in order for us to find the answer for sine, we have to know the opposite and hypotenuse. Well, we have our right triangle right here. The opposite side of this theta is going to be y. So this is going to be known as our opposite. And we know it's opposite because it's across from the theta. The hypotenuse is always the side that's across from the right angle. So we know that across from the right angle, the hypotenuse in this case is going to be 1. And I always spell hypotenuse wrong. I know there's like a U in there. Yeah, whatever. I say that's how you spell hypotenuse. So if it's right, awesome. If not, whatever. So being that that's hypotenuse, the other side's the opposite, that means the bottom part of this triangle would have to be the adjacent side, because adjacent means that it is next to the angle. So hopefully these 3 words are looking familiar to you guys: opposite, adjacent, and hypotenuse. The first part is asking us just to find the sine. So yes, right now, no matter what, the hypotenuse is 1. That could change in the future, but when you're working with the unit circle, yes, the hypotenuse will always be 1, Sierra. So if we look at sine theta, we said it's opposite over hypotenuse. Well, we just said what the opposite and the hypotenuse are. So the opposite in this case is going to be y, and the hypotenuse is 1. So all I'm doing is just plugging in what was in that triangle. What we were able to just determine is the sine value is always going to be y. And actually, I'm not going to box that in. I'm going to say sine theta is equal to y. So anytime we're looking for the sine of a function, it's really just going to be the height of the triangle. Okay? So now I'm going to do the same thing for cosine. It's the same exact steps. So when I go to do cosine we said up top is a over h, or adjacent over hypotenuse. Well, again, if I come over here and I look at the picture, we just said the adjacent side is going to be x. So I'll have x over the hypotenuse, which is going to be 1. I'm just waiting for it to write. Anytime now, notability. There it goes. All right, so now we have x over 1. And again, x divided by 1 is just going to be x. So based on our picture, based on what we wrote down, that means cosine theta is going to be equal to our x value. So in the future, if I ever ask you for the cosine, really all we're doing is just looking for the horizontal. We're looking at the x-axis and we're just trying to figure out the length of that triangle. And that's kind of like what we did in the notes the other day. It was the same thing. I asked you guys, hey, how far left or right did you go? How far up and down did you go? Now write it as a coordinate. It's just today I'm showing it to you with trig, and the other day we didn't use any trig. Last one is tangent. Up top, we said that tangent is going to be opposite over adjacent. Well, once again, we already know what opposite and adjacent are because it's in the picture. Opposite's going to be y, and adjacent's going to be x. That can't actually reduce down anymore. So in this case, tan theta is always going to be y over x. Which I'm also going to show you guys two things with that, because that means that if tan theta is y over x, that means tan theta can also be, well, we just said that y is the sine. And the x is the cosine. All I did was substitute in, since we said that it was y up here, I just plugged in sine for the y. I just substituted in. Same thing for the cosine. Since we said it was x, I just substituted it right in. That's why these are all equivalent. Y over x should also look kind of similar to you, because this is something that Miss Randolph showed you guys in geometry, and it's something that you guys have been doing in algebra, I mean, actually in math since like 7th and 8th grade. Y over x looks very similar to something, and it should, because this is slope. It's not the exact version of slope, but when we're talking about a unit circle, it is. Remember, slope is the change in y over the change in x. In this case, it kind of is, because if you guys recall something rise over run, this is saying that we're running x and we're rising y. So sometimes it may just say find the slope of a function, and that just means find the tan of the function. And again, you did some of those problems last year in geometry. We'll kind of expand on that within the next couple of days. All right. The only other thing I want to talk about with you guys today, so again, this was very brief. We're going to go into numbers tomorrow. I didn't want to do any numbers today. It's the first day back after a weekend. We haven't had a lesson since Thursday. So use today to finish up any homeworks that you guys may not have completed. Homework number 2, I put the due date for 9 o'clock tonight. Get it to me when you can. But the only other thing I want to show you guys is just talking about where trig functions are positive and where trig functions are negative. So this is a concept that I think you guys are going to pick up on pretty easily, because you guys have been working with positives and negatives for a very long time when it comes to grids. So when we look at this, first of all, I just want to rewrite up top sine theta is equal to y. Cosine theta is equal to x. And I want to rewrite tan theta is equal to y over x. Because the three things we just did up top is going to help us answer the questions underneath. So now that we look at this, the first part, we're in the first quadrant. So I'm going to go to quadrant 1. If we're in quadrant 1, I just want to know if the x value and the y value are going to be positive or negative. Well, since it's in quadrant 1, I'm going to use a different color here because I'm going to try to color code all of this. Since we're in quadrant 1, we know that the x is going to be positive because we moved along the right axis and then we went up, so that's also going to be positive. So again, if that is x and that is y, I want to know which trig function is going to be positive in that quadrant. Well, if we said that this was x, x is the same thing as cosine. So that means that cosine is going to be positive inside quadrant 1. We also said that the y value is going to be positive. So that means the sine value is also going to be positive in that quadrant. The last part is tangent. Well, tangent is the y value divided by the x value. Well, if the y value is positive and the x value is positive, and you divide those, a positive divided by a positive is also positive. So in that first quadrant, you guys will notice that all three of our trig functions are going to be positive up there. Now I'm just going to repeat the process, but I'm going to do it for every quadrant. So now if I go over to the second quadrant, I'm going left. So since I'm going left, the x value is going to be negative. And then I'm going up. So if I'm going up, the y value is going to be positive. So again, what I'm looking for in each quadrant right now, I'm trying to determine, it says we can determine when each trig function is positive. So I'm just looking for where they're positive right now. I know it says positive or negative, but I just want to write down the positive ones. So now if I come over here, again, this is x, this is y. Well, the x value is negative, so I cannot put cosine in this quadrant. However, the y value is positive, so I could put sine theta in here. If I go down and look at tangent, well, now tangent, again, is y divided by x. Well, if we do the positive divided by a negative, well, positive divided by negative is a negative. So tangent cannot be in there either. So the only trig function that's going to be positive in the second quadrant is sine theta. Okay? And I should label these just in case if you guys are forgetting. Quadrant 1, quadrant 2, and now we're going to move down to quadrant 3. When you get to quadrant 3, the signs when you go down there, you went left and you went down, so both of them have to be negative down here. Again, we don't know what the numbers are. We just know they're going to be negative because we're in the third quadrant. So once again, I only want to put down the positive solutions. Well, according to this, the x value and the y values are negative. So that means we cannot use sine and we cannot use cosine because both of those will be negative. However, if you guys do y divided by x, that's a negative divided by a negative. And in math, two negatives make a positive. So tan theta is actually going to be positive in this quadrant. And then finally, last quadrant, we went to the right, which is positive, but we're going down, so that is negative. So in this case, the x value is going to be positive. The y value is going to be negative, so that means only cosine is positive out of those two. And then if you divide y divided by x, it'll be negative divided by positive, so that cannot be solved. Or I'm sorry, it could be solved, but it's going to be negative. So the big thing that I'm trying to point out here is based on when we, and maybe I'll do one example before we go today, just to show you guys what we're going to be starting tomorrow. But what we're trying to do is we're trying to find if our solution is going to be positive or negative, kind of like what we did the other day by moving left or right, or up or down. So there's a little saying that helps us figure out which quadrant the trig is going to be positive in. So I'm just going to put down the letter A. I'm going to put down the letter S, the letter T, and the letter C. So we have our Silver Creek teachers. Oscar had a heap of apples. That was our little saying that we learned in geometry. The little saying that we use in Algebra 2 is add sugar to coffee. So this little saying will help us determine which quadrant our stuff is positive. So all means that all trig functions are positive in the first quadrant. S, or sugar, means that only the sign value is going to be positive. 2, tangent is only positive. And coffee, C, cosine's only positive. So it's just a little saying that we use. I'll write it off to the side. So add sugar to coffee. And that could be a little confusing right now. So like I said, I'll do one problem on the next page to show you guys what's going on. And then we'll do the rest of this tomorrow. So it's okay if you guys are a little lost. This is a completely new thing that I just put down. It's a new saying. I don't expect you guys to have an understanding right now. We got to do the practice problems in order for you guys to get there. So I'm just going to go down to the next page. I'm just going to do the very first one, and then we'll do the rest tomorrow. So we have sine of 30 degrees. So what I'm going to do is I'm going to solve this very, very, very similar to how we did it last week. So the first thing I'm going to do is I'm going to graph the x and y axis. And then I'm going to determine which quadrant 30 degrees is in. So if you guys did the homework the other day, all the steps that I'm doing right now are going to be exactly the same. So I'm going to figure out where the 30 degrees is in. Well, the 30 degrees is going to be in quadrant 1. So I have my initial ray. And I only have to stay right here in this first quadrant, and I have my terminating ray. And this angle right here is 30 degrees. If you want to solve for a trig function, it is very similar to what we did the other day. You have to create a right triangle. So I'm going to create my right triangle. I'm just going to go straight down and create my right angle. And this triangle should be something that you guys are looking at and saying that's familiar, because it's the same triangles I gave you guys on the homework the other day. This is going to be a 30, 60, 90 triangle. So I'm going to just draw a little triangle off to the side. So we have 30, we have 60, we have 90. Now, the nice thing about trig is I was showing you guys how we had to memorize the fractions on the outside, but there's a little bit of a shortcut when we do this, because sometimes you may not always be given a unit circle, and it can get a little confusing. So Miss Randolph showed you guys last year. She called it a 1 radical 2, 3 triangle. So this is 1, this is radical 3, and this is 2. We had them in as fractions the other day. But the reason why we wrote them as fractions is because sine is actually going to help us determine those solutions. So this is 1, this is radical 3, and this is 2. So again, we don't have the circle right now. That's why the hypotenuse isn't 1. So Sierra, when you ask that question, So no matter what, the hypotenuse will always be 1. That's if we're working directly with the unit circle. Sometimes we don't have the unit circle, so I just want to show you guys where this comes from. So now if you guys have something that looks like this, sine we just said on the other page is opposite over hypotenuse. So if I look at the opposite of 30 degrees, I'm going to have 1. And if I look at the hypotenuse, I'm going to have 2. $30 degrees is going to be 1/2 when we get into that quadrant. If I do it like a unit circle, I can go back to the notes that I did the other day. Where is it? Unit 2. And if I go to 30 degrees, actually, I could just look at this triangle right here. That 1/2 was there. So when I do some more practice with these tomorrow, I'm going to focus more around the unit circle this year, but I was trying to tie it into what you guys did with Miss Randolph last year. If you just have the fractions memorized, or if you guys just use these fractions that we did last time, it's going to come out so much easier for you. But I'm also going to show you guys that a lot of your answers can be checked with the calculator, and we'll do some calculator stuff tomorrow. Unfortunately, you guys only have your iPad calculators, though. It still works the same on the iPad calculators, but it could be a little weird. Fractions don't change. The fractions do not change, Sierra. It's just when you I'm trying to explain, when you guys learned it with Miss Randolph last year, she didn't give it to you guys as the fractions. She only gave it to you guys as those single values. So what I'm doing is I'm showing you guys the new way from this that we're going to be doing this year. So the new way, since we are working with a unit circle and the hypotenuse is always 1, we're using those fractions of 1/2 and radical 3 over 2. Since sine is going to be a y value, like I said on the front page, sine is really just the y value. The y value is the side of the triangle that goes up and down. If you guys look at this picture down here, the side that is going up and down is that 1/2. And I'm going to do some more tomorrow with this. So Sierra, I know you're going to be a little confused with it. It's okay. You're not the only one that's confused. I guarantee it. Once we start doing some more tomorrow, I have a feeling that a lot of you guys are going to feel a little bit more comfortable with this. It's just we got to get the practice in, and I only did one problem. But I don't want to go too much in detail with it. So we'll go and do the rest of this tomorrow. All these fractions are still going to be the same. And as far as this goes, B through E is just like going to be like part A. I'm going to show it to you guys with the fraction triangle so you guys can see where those answers are coming from, yada, yada, yada. And I'm also, shoot, Notability froze. Then I have to show you guys something, there it goes. Down here using Pythagorean theorem. You guys may remember Pythagorean theorem from last year as a squared plus b squared equals c squared. We're going to have to do a little bit of that, and then you guys will be okay for the homework for number 3. Okay? Yeah, stop by Zoom tomorrow, Sierra. I'm not going to go too much into it, but I'll show you like a little example off to the side. All right. So Shannon, I remembered. Yep. As you were typing it, it came to my head. So I'll send you the other lessons and homeworks. Shannon, do you have the ones from last week? Because I never got an email from you, so I just assumed that you were able to start downloading again. Because I'll make sure to send you those notes as well. But other than that, if anybody else needs anything sent to them, let me know. Anybody that's watching it on YouTube, hit me up if you got any questions. Other than that, that's all I got today. Go enjoy the rest of your Monday because, like I said, they're calling for rain every day for the rest of this week. Try to get outside if you can. I don't know about you guys, but I've been cooped up in my house for too long. So I will catch you guys all later. Have a good one.